This is the screencast for section 2.1, example 9, the sandwich theorem. So sometimes we have a function that we can't actually find the limit of. If we plug in 0 here, we get 0 squared times the sign of an undefined number. 1 over 0 is undefined. That doesn't mean it doesn't have a limit, though. The sandwich theorem gives us a different way of thinking about those limits. If we have a function g and a function h that f is always between, so for example here, g is this lower function, and then h is this upper function. If f is in between those two, as we approach our c value, f gets sandwiched in between the two because they would have the same limit at that c value. So for example, show that the limit x as x approaches 0 of x squared sine of 1 over x equals 0. Well, our f of x in this case is x squared times the sine of 1 over x. And we know from pre-calc that this oscillates between y equals x squared and y equals negative x squared. And you can see that the graph is here, so you can kind of already visualize what's going on. But when you're multiplying a trig function by another function, the trig function will oscillate in between the positive and negative version of the multiplier. So now if I look at the limit as we approach 0 of the upper function and the lower function, the limit as x approaches 0 of x squared is the same as the limit of x approaches 0 of negative x squared, which is 0. So since our function f of x oscillates between these two and they both have a limit of 0 at x equals 0, by the sandwich theorem, the limit as x approaches 0 of x squared sine of 1 over x equals 0. Now the two parts I needed for the sandwich theorem to come together was that our function is oscillating between two different functions, and both of those functions have the same limit at our c value, 0. Now there isn't a now try problem that goes with this example. You'll see examples in your homework, but we will explore the sandwich theorem again in section 2.3 a little bit more.